Today I'm presenting the cycle of creation of meaning and knowledge in meditation and other more cognitively engaged activities. I'm doing that in behalf of Robert Cosma, Florian Schubert, and myself. Our main research questions are: how does the brain participate in the creation of knowledge and meaning for values-based decision making and intentional action? How does this manifest in brain dynamics measures? How does pragmatic information relate to meaning and knowledge? We used a network of electrodes to measure EEG on scalp in 4 different modalities: scrambled words, ambiguous images, a video song, and mathematical arithmetical operations of a certain kind. Also, positive affirmations and meditation. We had a total of 20 participants in the experiment in these 6 modalities. We represented each electrode activity when recorded on a matrix that would allow us to display activity in the different cortices of the brain as displayed in this picture. We used the Hilbert transform of the EEG data in order to calculate indexes that were useful to our computations. And for that, we did pre-processing by removing artifacts of different types and the 50 Hertz oscillation, filtering the signal in the band of interest, and applying Hilbert transforms to the filter signals. From the Hilbert transform, we obtained the signal amplitude, the analytic amplitude, the analytic phase, the instantaneous frequency, and the pragmatic information indices. Our Hilbert transform methodology is applied to real signals measured by EEGs in many frequencies. We filter those signals with a bandpass filter, and then we choose a particular bandwidth, let's say gamma. Then we obtain a real signal, YT, in the gamma band, in a narrow band, which with 1 center frequency. After that, we use this signal and we Hilbert transform the signal to obtain a complex signal, ZT, where we analyze or compute angle and modulus. From the angle and the modulus of this complex system, we derive the analytic phase and the analytic amplitude. And from the analytic phase, we derive instantaneous frequency. We've observed in different studies, in past studies, that the relationship between analytic amplitude and instantaneous frequency shows approximately this behavior. It's important to note that the analytic amplitude is derived from the EEG signals across 128 channels or electrodes. The analytic phase we calculate also on 128 electrodes, and the instantaneous frequency we derive from the analytic phase by dividing the temporal derivative of the analytic phase by 2 pi. So basically, we obtain signals for the analytic amplitude of that form, for the instantaneous frequency, for the analytic phase, and this would be the signal amplitude for the 128 electrodes. From that, we can compute many things, like the mean values of all these signals, for example, which is shown in this side of the picture. A very important feature of an analysis is the pragmatic information index. Let us see how this works. The pragmatic information index we used can be found described in detail in a paper by Walter Freeman and Giuseppe Vitiello, by the title Nonlinear Brain Dynamics as Macroscopic Manifestation of Underlying Many Body Field Dynamics. They say that this ratio describes the rate of free energy dissipation to the rate of change in the order parameter, and it can be computed as the analytic amplitude square divided by the Euclidean distance, whether it is calculated from the analytic amplitude signals or from the analytic phase. They name this pragmatic information index after Atman, Spacher, and Schreiber. With the pragmatic information index, we endeavor to characterize the behavior of the cycle of creation of knowledge and meaning in brain dynamics. So this picture shows the behavior of the pragmatic information index pre-stimuli to an animal that receives a stimuli at the third second, which is a visual stimuli, and then brain dynamics changes for a period of 1 second, which is called the post-stimuli period. And in that particularly 1 second post-stimuli period window, we observe a very rich dynamics, which we segmented in different steps, like the O moment, which is the 100 millisecond first window of this 1 second window, the chaotic exploration moment, the aha moment, the chaotic integration moment, and the background noise again. The first 3 seconds of the experiment, the animal is doing what it does, and we call that the background activity. Here we present an example of the pragmatic information index behavior when extracted from the signals that we computed from the Hilbert transform. And we show that for this period of time, the analytic phases of the 128 signals are very close to each other, which means that the Euclidean distance between them is almost, very close to zero. And when we compute the ratio for this signal, we see that there is a raise, a dramatic raise on the pragmatic information index in this period of time. This raise in analytic amplitude is amplified by the fact that the Euclidean distance is tending to zero. So this is a good indicator of what's going on in brain dynamics at different times of measurement, depending on what kind of stimuli is presented and what that stimuli does to the brain or how it impacts brain dynamics. On this slide, we present a synthesis of the computations or the example we showed before in mean values. And here we have added a straight line, which we call a threshold, to calculate how many times the signal is above this threshold. As part of our methodology, we used an algorithm to compute the number of peaks per second in every experiment, and we did that for different bands and for different modalities. This is just an example of how we count the peaks above threshold. We're also able to display that for the different areas of the brain, like the prefrontal cortex, the frontal cortex, etc. And we can see here in the prefrontal cortex, we have a lot of activity of the pragmatic information index for this time window of the experiment, and also some aspects of the different times where there is some activity, significant activity in the occipital and parietal cortices, however, not so intense as the prefrontal cortex and the frontal cortex. Following, we present the analysis based on the mean number of peaks per second. For this particular participant, we can observe the number of peaks per second in every single modality or by every single band. And this analysis, we did collapse in a mean value for each modality and each band with their respective intervals of confidence. For example, we can see that here the modality of words and sentences shows a higher number of peaks per second than the modalities of meditation and ambiguous images. More of that will come later in our analysis. In this slide, we can observe that the modality of meditation shows significantly smaller values than most of the other modalities, if not all, particularly for three bands here, and that also some modalities like ambiguous images processing show lower values than for example, words. So that means that modalities can, or in principle, could be distinguished from each other based off the number of peaks per second that we compute for each modality in each band. And the same happens here. We can observe that the theta band is less active, for example, than the gamma band. Okay, this will serve the purpose of further analysis, as we will see. Here we can observe that the modality of meditation shows statistically significantly lower values, since the interval of confidence is below the mean of, for example, this activity. However, words, but images and meditation show similar values when we compute the interval of confidence of these two modalities. These two modalities appear to be the lower valued based modalities when compared to others. That's an interesting feature of this analysis. And the high gamma modality has significantly more activity than all other bands and all other modalities, while all the rest of the modalities seems to be pretty similar, apart from alpha, that has also significantly more activity than most of the modalities. And that shows perhaps the linkage between the bands gamma, high gamma, and alpha, which has been reported in the literature before. Here we show the numerical values for the interval of confidence of the different modalities and bands that we measured, and we highlight how the modality of meditation shows an average number of peaks per second significantly smaller than the number of peaks per second for the activity or modality of sentences. Now, for the alpha band, this seems to be not so, since the interval of confidences overlap, as you can see here, between the modalities of med, words, and sentences, for example. We highlight this as an example, but there is a lot there to be understood. A first summary of this analysis is that we observe a significant difference between meditation and other modalities, and we also observe a linkage between alpha and high gamma, and between theta and low gamma. We have explored how the brain responds when creating meaning and knowledge for intentional action based on the legacy of Walter Freeman. We find these results very promising in the understanding of the neuroenergetics of brain dynamics, and that, we conjecture, may lead to a healthy and meaningful life where we learn from our inner states and behavioral responses based on meaningful salient events, people, moments, and our most cherished values, like love for our family members and friends, for example. Our line of research is mainly concerned with how the brain-mind complementary pair manages to do such a marvelous job, the job of producing our long-lasting meanings and values that refine our intentions and the quality of our decisions. It is possible that if we manage to shed more light on this subject in the future, we may contribute to the development of the human potential in association with the quality of the human being and his or her spiritual constitution and behavioral responses, something that could be explored both experientially and scientifically from an early age. Meanings are veiled to brain dynamics measurements, yet they are very salient and revealed in human experience. This forces us to consider that the creation and valuation of our most precious meanings ought to be understood by first and third persons perspective science, which means the study of brain dynamics and the neuroenergetics of the brain, hand in hand with personal reports and anecdotal veridical evidence based on subjective experience. We are dedicating this work to the memory and the spirit of our beloved friend and collaborator, Walter Freeman, who will always be alive with us in our quest for the understanding of meanings and intentional behavior.